Right now, we have a crisis on our hands.
We're losing the fight.
The fight against germs.
Antibiotics have been successfully treating infections for years, but if we don't act now, we may no longer have that luxury.
The scary thing is, the enemy which we're fighting is constantly adapting, evolving, and escaping our best weapons, antibiotics.
Now, when you take into consideration that you can't see them with our eyes, it makes the situation a lot more complicated.
In fact, the WHO has predicted a yearly death toll of 10 million people due to antibiotics becoming less effective against infections.
So how can germs, organisms so small, result in the deaths of millions?
Let's hear what a physician has to say about it.
Definitely, many kids are on their third or fourth antibiotics since the second half or the summer or spring of 2022. There's definitely a lot of babies that have been taking antibiotics for ear infections, and we do see failures to treat. I even had a pneumonia that didn't respond to amoxicillin, and I had to give them a cephalosporin, a second-line cephalosporin. So we are seeing resistance.
So we know antibiotics are becoming less effective against infections due to antimicrobial resistance.
But how does this happen?
Let's take a closer look.
Bacteria are found everywhere, but antibiotic-producing bacteria are most commonly found in soil. Yes, you heard that right. Antibiotics are made by bacteria. The first antibiotic was discovered by Alexander Fleming, by accident. He was growing bacteria and forgot about them. When he returned from a vacation, he noticed that some of his bacteria were dead. This was because the mold that started growing produced a compound that killed the bacteria. This led to the discovery of penicillin.
Bacteria can't be seen with the naked eye, so let's zoom in further and see what we can find. Here we see 4 different types of bacteria shown in blue, green, purple, and yellow. These bacteria are all taking part in biological warfare, where each type of bacteria produces their own antibiotic. These antibiotics will kill other bacteria except itself. This is one of the many ways that bacteria protect themselves from others. So in this region of the soil, we see that the yellow bacteria are surviving, where all the other types of bacteria die.
When we don't wash our hands, we can spread bacteria everywhere. Now, let's say someone prepared some drumsticks without washing their hands. These bacteria are now hitching a ride on the drumsticks. Now, when this person eats the food, the bacteria will be able to enter the body and start an infection. The person would never know it's contaminated with bacteria unless they held up a microscope. This is why it's so important to be careful with what we touch and how we clean our hands. Now let's zoom into the stomach and see what's happening.
Now this bacterium alone is not much of a threat, but the issue is that it's able to multiply by a process called binary fission. This allows the bacteria to divide in 2 in a matter of minutes, and this number of harmful bacteria in the body continue increasing exponentially. Now we have this infection in our body and we start getting extremely sick. What do? We'll go to the doctor and they'll prescribe us some antibiotics. This treats the infection by killing the bacteria.
Sometimes, a few harmful bacteria adapt, evolve, and escape the effects of antibiotics. This can happen due to a mutation in the genes of these dividing bacteria, allowing them to become resistant. Resistance to the antibiotic involves either pumping it out, breaking it down, or preventing its entry. This is a huge problem because it only takes one resistant bacteria to carry on dividing and continue the infection.
Now, this could eventually birth a superbug, a multi-drug resistant germ that is unable to be killed by antibiotics and medicine available. Right now we have 6 main superbug strains on the WHO most wanted list. These are the Eskape pathogens. The Eskape pathogens originate from hospitals due to high amount of exposure to antibiotics in extremely sick patients.
The Eskape pathogens are just the beginning. There are many more bacteria that pose an urgent threat and even more on the WHO's watch list.
So what we've just explained was specific to bacteria. Resistance can actually occur in all types of microbes, for example, viruses, fungi, and parasites.
Antimicrobial resistance can affect anyone, anywhere, anytime.
Now, we've all taken antibiotics before, whether it's for something as simple as a UTI or for something more serious like pneumonia.
So how do these antibiotics work?
There are 2 ways, either by killing the bacteria directly or by stopping its growth and division.
Whenever threatened with something like an antibiotic, the bacteria will always find ways to survive. An example is obtaining an antibiotic resistance gene, like we've previously mentioned.
Overusing and misusing antibiotics are the main contributors to their evolving resistance.
That's some pretty scary stuff, huh?
Now, hopefully, you'd be wondering, what can we do to help?
Here are the easiest ways. Don't take antibiotics when you don't need to. Always finish your prescribed course, even when you start to feel better. Wash your hands with soap and water for a minimum of 20 seconds. Get vaccinated, and practice proper food safety.
Now, it would be a shame to watch a century of progress in healthcare and medicine unravel. We need new drugs, therapies, and most importantly, your help to tackle this antimicrobial resistance crisis. So join the fight, spread the word, not the germs.